You have to have the right, did you write essays for your
For my applications for what?
college?
What?
Like did you, I guess.
Yeah. Did I? Like when I was in a student in college?
Yeah,
Did I
and
have
like high
essays?
school. Going up, back upon college, did you guys have essays?
Oh, so when I applied, so I was different because I was not a good high school student, so I didn't know I was going to college. So I didn't agree to college. Like I didn't try the first time, and the second time I only tried on computers before or something. So no, I did not write it. No, you want to see this?
That's so.
That's not fun. Banner. And it's not fun. And two people behind didn't even know where the banner to the third floor of our college. I think I ran around some people in the stairs. Jesus here, I saw him here.
Okay, good morning, guys. I would like your integration by parts homework turned in, please. And then you need to find assignment 8 in your binder. This is where we start talking about improper integrals the last 20 minutes of class. So we're going to start off by reviewing what we talked about last class and then finishing the notes. And the bulk of class today, we'll be practicing that skill. The other handout that I had you pick up on your way in, I would like and hope that you get part of the way through it, partly because it's a bigger handout, but it's not due tomorrow. I'm not going to expect you to turn in assignment 9 tomorrow, but this is a review for the first couple of pages, mixes up all the integration types together. You don't need to try to do the notes at the top. We'll do the notes at the top together. But it's got some integration types mixed together. So some stuff from AB, like a trig identity or antiderivative of 1 over x and undoing the power rule. Some of it's pretty easy, a couple U substitution questions, but it also mixes in a couple partial fraction questions and a couple integration by part questions and a couple improper integral questions. So the first few pages of that have them mixed up, and so even if you don't do much of that, if you at least do some of the easier ones that you could have done last year, it'll give you less to do tomorrow, and that'll probably save you some homework. The last couple pages are 6 of each of the new BC topics before we get to that first quiz. So there's 6 partial fraction questions, make sure you're good with those, 6 integration by parts questions, and 6 improper integral questions. So that's why it's a little bit longer of a handout. And 2, 4, 6, 8, 10, 12. Does anybody know Alvin? He hasn't been back yet. Okay. Okay, so what we talked about with improper integrals is first you just need to know what an improper integral is. So again, let's just very quickly talk about the parts we did last time. So an improper integral usually is when one of your limits of integration is either negative infinity or positive infinity. This is the most common type. And it's a pretty easy fix. All you do is you're going to not put infinity here. You're going to put a variable like t, and then put the limit as t approaches infinity. So our antiderivative is going to work out the way we've been doing them. A lot of them are easy. 1 or 2 might be U substitution. I think at least one's integration by parts, and at least one's partial fractions, which is good because you need to keep practicing those. But you're still going to evaluate from A to T, so you're going to plug in T the first time, A the second time, A is going to be a number, and at the very end you take the limit and you're done. So again, not much new, if any, calculus in this, but it's really just trying to connect limits with a different type of antiderivatives you haven't done before. Also considered improper, do you guys remember why negative 1 to 1 doesn't work for this?
Because it's not continuous over that stretch.
And specifically not at x equals
0.
Right, so negative 1 to 1 includes 0, but this is undefined at 0. So this is also considered an improper integral. So looks like I'll have to zoom in here. They made me change this. So if I wanted to integrate 1 to infinity of 1 over x to the 4th, again, the visual of that is that's like asking how much area is there under that curve to the x-axis from x equals 1 to x equals infinity. So even though this piece gets infinitely small, it does keep going forever. But again, now I'm not saying that all these questions are easy. The questions can get harder, but the new concepts that you try to have to try to add to your wheelhouse is I change the infinity to a t, put the limit as t approaches infinity. I did the antiderivative the same way. I evaluated from 1 to t the same way, but to get my answer, I had to try to plug in infinity for t and figure out where this stuff went. Because that went to a finite number, like a third, sometimes we refer to that as saying it converges. Converges just means it heads to a number, not infinity or negative infinity. The other example we did was this one, and I tried to show you that the graphs look pretty similar. So if you just say, I don't know, this went to 1/3, maybe this goes to 2/3, you shouldn't do that. Sometimes it's hard to tell. So same thing, I changed this infinity limit to a t. I put the limit as t approaches infinity. Sorry, I didn't. I had to change programs here, so it made this a little bit lighter. Antiderivative's the same, evaluating from 1 to t is still the same, but at the end you have to plug this in for t, and because all of that goes to infinity or negative infinity, your answer is that it diverges. Converges is when it goes to a number, a finite number. Diverges is when it goes to infinity or negative infinity. I'm not too concerned with you knowing the names converge and diverge at this point in the year, but I'm having to say that because when you check some of your answers, it's not going to say infinity, it's going to say diverges. So I need you to know that's the same. And so not until Unit 10 will this really matter, but this setup here, which is like those top 2 questions, if it's ever this setup, you can just look at this p-value. If p is bigger than 1, like example 1, it converges. Now it doesn't tell you what it converges to, but it tells you it converges. And like example 2, if p is less than or equal to 1, then it diverges. So really, if it fits this format and you're willing to memorize that, I guess you could know that this diverges by skipping those steps. But it's not that those steps are all that difficult anyway. So that's the stuff that I threw at you the last 20 minutes of class. Before we continue and knock out the rest of the notes so you can practice this, is there any immediate questions about what we discussed there? Okay. So let's look at the rest of the notes. So this is similar, just slightly different take. So question 3, what if they are both infinity limits? One is negative infinity, one is positive infinity. So in this case, what you need to do is you actually have to split this up. This is what they're telling you up here in the notes. I'm just explaining it to you. So again, just like when we started this, just like when we first started integration in January, I said always just think of it as area under a curve because that gives you a visual. This is asking for all the area from negative infinity to infinity, which is the same thing as the area from negative infinity to 0 plus the area from what to what?
0 to infinity.
Right. So split it up into 2 parts like that. Now we can do what we did on the front page. I can change this to a t and do the limit as t goes to negative infinity out front. Over here, I'm going to change infinity to, I don't know, something. Why don't I want to use t here, by the way?
Negative infinity and positive infinity aren't the same.
Right. You don't want t to represent 2 different things. So pick something else. It doesn't matter. I'll pick b. So the limit as b goes to infinity. Now this is going to get messy for a second, but again, all I'm doing is splitting this into 2 integrations. Both of these antiderivatives are as easy as it gets. The derivative of e to the x gives you e to the x. So right here, this antiderivative would be e to the x from t to 0. So that, sorry, let me try to squeeze this in a little better. So e to the x from t to 0. So that's going to be like e to the t minus e to the 0. And in a second, the last step should be really dealing with the limit. And then this guy over here, you need to carry the limit down. I know it seems like you're not doing the limit till the end, so why not just write the limit at the end? Don't develop that habit. You can miss points on an FRQ from not showing that. You're likely to forget about it if you're not writing at each step, and it's considered a linkage error. This doesn't really equal this, doesn't equal this, doesn't equal this, unless you are putting the limit part until you're done with it. But e to the x is still e to the x. Evaluate from 0 to b would be e to the b Wait, you guys not going to say anything over here?
It's e to 0.
Yeah, I plugged these in the wrong direction. So this would be e to the b minus e to the 0. Okay, and then we're basically done. I know it doesn't look like it, but we're all but done. E to the 0 is 1. Anything to the 0 power is 1. If I tried to plug in negative infinity here, what does e to the negative infinity go to?
0.
It it does go to 0. So if you don't know why, remember negative exponents, you can move them to the other side of the fraction to make them have a positive exponent. And then you can see that your denominator's unbounded, whereas your numerator's bounded. Unbounded just means it keeps growing forever. Bounded means, you know, we've got it caged in. So that goes to 0. Okay, plus, if I plug this in, if I try to plug in infinity for b, e to infinity, well, what does e to infinity go to? Okay, and now technically the plus 1 minus 1 cancels, the minus 0 does nothing, but I don't really care because if part of my answer is going to infinity or negative infinity, we're just going to say that it diverges anyway. So for the graph e to the x, if you're willing to go further and further to the right, it's just going to get more and more area. It diverges. Now, I didn't think to do this with my 3rd period class, but let's just talk about the graph for a second. That should make sense to you. E to the x, okay, I have no idea what's going on there, but you guys know what e to the x looks like, I hope. It's like all exponential growth graphs. It looks like this. So from negative infinity to 0, okay, maybe that doesn't have a ton of area, although it does get a little bit because this only approaches. But look right here. If you just keep going to the right, don't you see that the area just keeps getting bigger? So if you're trying to find the area from negative infinity to infinity, that area is going to infinity, which is what we got. It diverges. But what you need to get out of this question is sometimes you might want to split it up into parts. So in that case, this was negative infinity, infinity. That's why I split it up at 0. You could split it up at any number you wanted to. You could split it up at 1 if you prefer. It's just that 0 makes a lot of stuff algebraically be kind of nice. So that's why most people pick 0. Okay, the other thing, and this is basically the same idea, but just so you know mathematically, if this guy is only continuous from A to B, include A and don't include B, that means we can never actually plug in B. So what we would have to do here is rewrite this as some number A is a generic number, but for B, again, B is a number as well, but I don't want to include it. So I'm going to say T, and I'm going to say the limit as T approaches that number, but from the left. Think about it. If you're going from A to B and you can't go all the way to B, you can approach it from the left side. So you're going to put that, and honestly that doesn't change hardly anything about the question. Like, it's still going to basically work out the same. But you need to understand why there's supposed to be a minus sign there. You can't include B, so we can go up to B but not include it. So doing this is going to be the fix. Whereas on the other side of the coin, maybe you can actually reach B, but you can't only approach A. So instead of saying A, I'm going to put T. I'm going to leave the B number alone. The function's not changing. I'm still going to do antiderivative. But now I'm going to do the limit as T approaches
Positive A, and then from the right.
Good. How do you know it's from the right? You're right, but this is saying you're supposed to take the values trapped between A and B, right? But you can't actually get
would
to
be
A.
on the left, so you're just...
Yeah, so you can only approach it on the right. It doesn't make if you're approaching A from the left, like, you can't even include A, let alone include things to the left of A. So you got to approach A from the right. Up here, you cannot get to B, but you can approach B, but you're coming from the left. That's why this needs to be a minus. So again, realistically, it's not going to change much of how you do anything, but question 4 has us make sure that we can address that. So let's do these last 2 examples together, and then you guys can start trying some of this as well. Okay, so my first question is, how do you know number 4, why is this considered an improper integral? Because infinity and negative infinity are not the bounds.
Fraction on the bottom.
Okay, well,
Sorry,
you're close, but this is not considered an improper integral, even though there's a fraction.
No, I meant because there's a root on the bottom, not.
Okay, well, I could go from 1 to 3. That's also not improper.
It's been divided by 0.
At what x value?
0.
Right, so you see how 0 gives us division by 0? So we actually, mathematically, we're not allowed to plug in 0. The way around that is we're going to say, well, I'm going to approach 0 from the right side. And again, it's basically going to work out the same. But so this is the same as, instead of going 0 to 2, I'm going to go t to 2. And at the end of the question, I'm going to take the limit as t approaches 0 from the right. If you can do that limit at the end, this is the only step that's really different. Again, it doesn't mean integration is all of a sudden easy. If I remember correctly, I should remember because it was just yesterday, but yeah, just even glancing at these in that 2 seconds, I know at least one of these, the antiderivative, you're going to have to try to do partial fractions again. One of them is going to make you do the integration by parts formula again. So I'm not saying that this all of a sudden becomes easy, but the new parts you're adding to it shouldn't be difficult. So when I look at this, I see that this would be u substitution. And I'm just going to go through it fairly quickly. I know you guys are familiar with that, so. Okay, so if I do this, I could do 1/2 du, and this becomes 1 over the square root of u, which is like that. This is why I made you do that u substitution the first day, so that this wouldn't be as rusty for you. Don't forget to change your bounds. T to 2, I hate that it does that. T to 2 is if you're talking about x. If you're talking about u, it's something else. So when x is 2, u is 12. And when x is t, u is t squared plus 4t. Antiderivative is still going to work the same. Raise the power by 1, divide by the new power. The evaluating is going to be the same. We're going to plug in the top first and then bottom second. So this would be like the square root of 12 minus the square root of t squared plus 4t. And now finally I can deal with the limit piece that I added to it. So there's no t stuff here, leave this alone. This is 0 from the right because again it doesn't really make sense to go exactly at 0, but this is where if you forget to put it, it's not going to mess up your final answer. Could make you miss a point in a free response depending on what you're looking for. But you're still basically plugging in 0, so what does this go to? Okay. So your answer is square root of 12 minus 0, or the square root of 12. As a multiple choice question though, why isn't it going to say the square root of 12?
Because they expect it to be simplified to be the 2 square root of 3.
That's correct. So they're probably going to simplify the radical. But again, at a glance, you're doing a lot of stuff here, but you need to not overreact that it's harder than it is, because u substitution, you're going to just keep getting better and better at. Evaluating is the same. U substitution's the same. You just have to sometimes know, throw this limit out front and change one of the bounds so that you can find a workaround from what you need. Okay, and then finally, another one. I don't think this one has anything different in it, but they're telling us to split this up. So we talked about that at the top of this page. If I want everything from -1 to 1, that includes 0, and I'm not going to be able to plug in 0 here. Division by 0 is not okay. So instead, I'm going to take the area from -1 to 0, and then add the area from 0 to -0 to +1. Now, there's still a problem here, and this is why they put this example here, not on the front page. I can't plug in 0. So mathematically, our workaround is I'm going to change this to like t, and I'm going to say t is going to approach 0, but from the right side. Since I can't really plug in 0, but I can approach 0 from the right side. That's my workaround. Again, the arithmetic and the way you get your answer is still basically going to be the same, but mathematically, this is what's really happening. And then same thing over here. I can't really directly plug in 0 into this because it's not continuous there. So I'll change this to like the limit as b goes to infinity from the left, and I'll make this a b instead. Okay, the hard part's done. This is still antiderivative. That's one we have memorized. We are still going to evaluate it from -1 to t. Do the limit at the last step. Do the same stuff with all of this. Carry the limit down. The limit needs to be there until you're done. Natural log absolute value of x from b to 1. I'm going to just erase this. This would be plugging in 1 first, and then plugging in b next. Now, I don't usually see a good opportunity to bring this up, but when we integrate 1 over x, what do we get? What's the antiderivative of 1 over x? It's not just natural log of x. It's natural log of absolute value of x. You know how I always keep saying don't forget the absolute value? Well, here's where you need it. Because right here, -1 doesn't exist with natural log. That doesn't make sense. Nothing to the power of e is going to give you -1. But because the absolute value signs are there, this is like a +1, and the natural log of +1 is 0. What about this? If I come from the 0 from the right side of this, what does this go to? You have to think of the graph. What's a natural log graph look? What do all logarithm graphs look like without transformations? So as you approach 0 from the right, this is approaching -infinity. So now that I can see infinity or -infinity is part of my answer, you can keep working this part if you want to, but it's going to diverge. So I would just wait and say diverges. This I have up over here, so I think I've pointed this out a couple classes in a row. Maybe it was my 8A class though. Knowing what the natural log graph looks like helps you see why approaching 0 from the right goes to -infinity. So, diverges. Okay, so quite a bit going on in those questions. That's why you got to practice them a handful of times. But of course, they kind of start you off a little bit easier. Seems like from yesterday, number 8 was the one that gave people the most trouble, but we can just talk about that when you guys get there. So, Looks like you've got 11 practice questions, but the last 3 are test prep, multiple choice type. So go ahead and just dive into it, see how it goes. Check your answers on the website to make sure that you're doing it correctly before you just keep trucking along. We've got about 20 minutes till lunch, so if you could do 2 or 3 of those, that would be great. Again, this is our focus, the whole class. So if you need all of the time after lunch to finish up assignment, this assignment 8, if you're starting to practice, that's fine. Assignment 8 is what I will expect you to turn in tomorrow. The number 9, today's handout, if you have time to do some of it, it will mean you have less to worry about next class and probably less homework between Friday and Tuesday. So, but improper integrals is your main focus this morning, or this afternoon now. We're after 12. Okay, let me get these homeworks put in, and then I'll let you know when I'm done with that so I can help as you need it. And like a lot of these handouts, you can see there's not a million questions. I'm not trying to get you to practice the same skill over and over and over again. So, because some of these questions take a little bit longer. But the trade-off is you really need to put your best effort into each one, because each one is trying to make sure that you can adjust the different situations. So. Everybody else turned in their work up. Okay, I'm done with homeworks. So after you finish question 1, if you don't have the same answer or you got stuck and can't get to an answer, I need you to tell me as soon as possible. If you're having trouble with question 1, you're probably going to have the same problem or same issue in a following question anyway, so. No point in waiting and getting it corrected. I'm sorry if I've asked this a million times, but just to be clear, nobody else wants to check out a calculator for the year? Okay. I'm going to let some of the other AP teachers let their students start checking them out then. everybody okay with that question 1? Everybody finished with that one and it's good? Okay, just glancing at number 2, I can quickly see that the antiderivative work in number 2 is going to be partial fractions. So you're going to have to go a little bit slower on that part since that's brand new to you. Is anyone finished with number 2 and know you need help with it? Okay, go ahead and keep going then. You got about 10 minutes. So if you can get another question or 2 done, that would be great. And when we come back from lunch, I will start off by seeing if y'all needed help with 2 root 3. Again, I know you guys aren't this far yet, but number 8 was the one that gave people the most trouble yesterday, so you might save it for the very last question. You might save it for after number 11. And of course, we can talk about it together in class, but I would like to wait to make sure everyone's there at the very least.
so that they can probably see the babies in your bag and not your.
What
You
if
also
you just
get
had something in your bag though?
I set off the metal detectors today and I've never set them off before.
I set them off today and nobody called me over, so just
Cheated the system?
No,
Just keep walking.
So there's a nice
What
lady
illegal
that does it.
contraband did you bring in here?
I don't know, maybe my water bottle or my 3-ring binder. But
My 3-ring binder's gonna set it off. I don't think that's what's setting them off.
on Monday or Tuesday, I also set it off, and the lady was like, "You're fine, just go." But then
You just
another
gotta
time,
get in later in school, the school day, I
She
think.
was like, "Go to Mr. Ziegler," and he just like took one of those wooden dowels,
Sticks.
and he just like hit my backpack with it. I was like, "What's that gonna do?"
Like,
I don't know. He just
I'm
like
gonna be
tapped
so
it around
upset.
on my
Is that
backpack.
gonna help define like what they're actually looking
There's like a bomb that probably like set it off.
No,
We don't even know.
some kid's gonna actually carry a weapon through the school and like they're not gonna actually check for
Yeah, I
it.
don't think it's.
I don't think
Because it's very much like the way that I've seen it. They like look at you and they're like, "Would you please take that?
Yeah.
Would you not?"
Well,
So, like,
I came in after band and like there was one lady there. And mind you, there's 150 kids trying to get into the school.
Yeah.
It's like,
Does it make a noise or just go like a different color? if you
It makes a
set it off?
noise.
Okay. Then
no,
I don't
but it
like that.
doesn't, but it also makes a noise if you don't set it off.
Yeah, but
Same
it makes a
time.
difference.
Yeah.
Okay, because I don't like look or anything, I just keep walking, so I don't think I've ever set it off.
I've set it off every time.
Or if
I've
you
only
just
gotten
keep
checked
walking,
once.
really, it's just stop.
I've never changed
Well, if you
what's in my
switch
backpack.
these two
so
around,
I'm
yeah,
thinking if I
I
just
think
keep
it
it how it is.
All the
it's
time I've
just-
set it
These
off,
are both
I'm almost
natural
positive
logs,
it's
and they would
because
be
someone
separated
is
by
holding their cover
subtraction.
behind me and
They
trying to
condense them with
Yeah.
division.
There's
So
this
they're
problem.
condensing
No,
that.
because I saw that happen.
And the
today
reason they're
with the band
condensing
kids.
that.
Okay, to be fair,
because
today
now
I
since
brought
this
in
is
my
going
2
to
spiral
infinity,
notebooks from
if you
English
think
last year
like
because I know
horizontal
someone who wanted
rules,
them.
at this fraction,
So I
it's
gave them,
closer and closer
but like,
to 1.
I already have spiral notebooks in my backpack, so I don't know why it's in
Why that works that way?
Yesterday I was carrying around
Dang.
spiral notebooks and I had
So
like
remember when you
2
compare like the
different
degree of the numerator and the degree of the denominator?
Yeah.
And my water bottle.
Figure out which
Like, that's
one
the
is
only thing I
better.
did. I mean,
These are
I
both
didn't
one.
take out my old
Oh, so
backpack,
it's-
but that should be.
Yeah, so
a-
you're
Yeah,
looking
that
at
was
it. So all that does for one,
I
a
remember-
natural log is something that does
It's
for
like,
one.
yeah, they changed it to like where you put on the
Just
boots
like-
that you're coming with instead of the full thing, so like you have to like put it down and then you
So-
have to like go.
You gotta
Because
do a little
sometimes
bit of
if you don't put
gymnastics
it
there
on,
and
it's
then
gonna
figure out
like
how to
reach
get
over when
it.
you go and pick it back up, because the tables.
Looks like you got the important part down.
No, the
They
lady
should have the airport things where you
Where
set
like-
it, the rolls.
Oh, okay.
Wait, how do you know?
But I bet they spent all the.
Okay,
rest
no, let me
off
start
the-
with the notes. Number 5 on the notes.
Yes.
Okay.
Honestly, I would rather.
As a clarification.
Immerse someone really
Okay.
who went to school and then have to go through notes.
So remember when you said like on this,
Rather not have those.
we're approaching from where the bones are?
What?
Yeah, do you know what?
Well, you're
I'm
gonna do the
sick and tired of
point A and B,
taking
and you
kids
can't
to
actually
second
read
week
the
school.
you gotta come from the left.
Yeah, on this one.
And no phones.
That's what we're trying to approach, we're approaching
What?
from the right.
No, the whole reason we got
Yeah,
phone
that should've been
detectors is
from
because
the left.
parents were concerned because kids wouldn't have access to phones. Well, that's
All right, make sure you're back at 12:50.
She's coming. I don't know which route she took.
Better, so like, now how do you feel about
You also started counting backwards from 1,000.
I've tried that before.
I can only get to like 700. But last time I 108. So I'm going to number. No. It's like a psychological thing where if you count backwards, it's supposed to help you sleep. So I counted backwards from 1,000.
Oh, I got it.
And it's been working, but last night it did not. Cause I
Any games recent interest you lately?
I have been playing, and I'm on the last boss of a game called Another Crab's Treasure.
Oh, yeah, it's that Souls-like game.
Yep, it's pretty good.
Yeah, no,
It's
I've
pretty funny.
I've heard of that.
I'm not great at Souls types games, and that one starts off kind of hard, but then it's not too bad. It's enjoyable.
I
very
haven't
good.
really played Souls-like games, but I think I'd be pretty decent at it because I do a lot of Monster Hunter, and I hate when people say it's like that is like a Souls-like game, but you can. It's definitely a lot of similarities with like just like predicting patterns and stuff.
Yeah, I haven't played the Monster Hunter, so I don't know.
Yeah, it's not for everybody. Also, the new one requires quite a rig. Honestly, they didn't optimize it too well.
I play a brass instrument.
Yeah, that was so nice. Smashed my birthday, but I still.
Is Denny gonna make it?
But I don't. Has to get like size.
The ugliest thing ever.
Why is it showing me?
No, the image search is like.
The image search is messed up.
Yeah, I don't know what they. I don't know how you break that, but you know they did.
Who practices like? It's like on the football field, behind the bleachers. There's like the group of people that are like behind the bleachers.
Oh yeah, those are the ultimates.
Okay, Denny didn't make
Not
it.
unless you heard them. No. Can't imagine. I've been marking this for 10 years.
Okay, I promised when you guys went to lunch that I said I would start off by offering to try to help out with the first few. So I think I already offered question 1, but what about number 2 or 3 or even 4? Any of those you want me to help with? 2, 3, or 4?
I just had a question on number 2.
Okay.
The answer is like, does negative infinity cancel out positive infinity of Ln?
I would not assume so. The problem is they could be going to infinity at different speeds, so I would not assume that. But if you're doing the natural log of infinity, natural log of a value that goes to infinity would be infinity. Because in the natural log graph, the bigger x gets, the bigger y gets. But Denny, what about you? Since you were late.
I got dragged in Dr. T's class.
I doubt that.
He told me to come inside.
He told you that?
Yeah, he saw me walk past and we come in.
And you got a late pass from him?
No.
Okay.
I mean, he had a lunchroom, so it wouldn't be too far. Probably didn't take off.
I understood.
This is spoon.
I
Okay.
Done my math wrong.
Let me get out of your way then. Again, number 8 is the probably the most challenging question on here. So if you want to attempt 8 when you get to it, great. If you want to save it for the last question, that's fine too. But ideally, you guys finish this up this half of class. That would be best case. And even better if you can get a jump start on assignment 9. Now, one other thing I want to point out, from what I can tell, you know, obviously we haven't had a big quiz or anything, but based on y'all's questions, it sounds like you're progressing just fine. I just want to put the asterisk, even if you find this stuff to be difficult, make sure that you stick with it the best that you can, because remember, BC topics, there's not that many BC topics. So you guys have already seen these 3. This is it for integration. There's no more new types of integration you have to learn for BC. So, once you get these 3 things down that we already talked about, there's 1, 2, 3 random skills we'll do. And then we can do all of Unit 9, which is 2/3 of that is actually pretty easy. And then we've got Unit 10, which students struggle with, but we've got lots of time to deal with it. So, even if you think this is hard, stick with it, because it's percentage-wise, it's a bigger percent than one random thing would have been an AB. And then, of course, by starting the year with this, if it ends up being something that just takes you a long time to get, at least you've got plenty of time to get it under your belt and be ready for it on the AP exam.
But I don't know. Does this doesn't it diverge? I'm not crazy.
Infinity is equal, but you forgot your little negative on it.
Did I?
So
Oh, I
there's also
see.
one
Yeah, so it goes to the bottom, which means.
This is
Okay, I get it now. Shows the amplitude, like, what?
I literally just started
It's
that one. When it is, can't see. When you do the antiderivative, it's tangent to the negative one.
Oh, that's right.
Instead of x.
guys know you can ask questions at any time, but all right. Yes, what you got?
On number 5, some of like the
Okay. Let's look at it. And it gives me a chance to record it anyway, and I can put it on the website. Somebody else will get some use out of it too. Okay, so first part of question 5 here is we got to deal with these negative infinity, so I assume you're okay with that. That would be like maybe the limit as b goes to negative infinity from b to 0 plus the limit as t approaches positive infinity from 0 to t. Obviously you might not be using b's and t's, but same thing. Dx. Okay, so we're roughly on the same page there. Okay, so we know the limits will be the very last thing we get to take off our plate here. Okay, now to be fair, if you don't remember this antiderivative, I would totally understand, because it's one of those that we just don't use a lot in AB. On this review sheet tomorrow, though, I'll make sure that we talk about the two you need to know. So this is arctan, or inverse tangent, same thing. Same over here. 0 to t. You're okay with that? Okay. This is b to 0. So plug in 0 first. So this we can find a numerical value for. Minus plug in b next. And then for this limit, we're going to plug in t, and then plug in 0, and then subtract them. So based on your question, it sounds like this is about where you start having trouble. Okay, so the difference here is inverse tangent of 0 is not asking you what's the tangent ratio at 0 radians. It's asking you what's the angle in radians where tangent is 0. So between negative pi over 2 and positive pi over 2, when is tangent 0? At what? At 0. Since tangent sine over cosine, when sine is 0, tangent is 0. So this, again, this is like a mathematical way to say what angle has a tangent of 0. So that's why that goes to 0. Right here, I'm just going to plug in the negative infinity, and we can talk about that in just a second. Okay, over here, I'm going to plug in the positive infinity, and we can take care of that at the same time we take care of this, so give me a second there. But then right here, this would be minus 0 again, since it's the same thing. Okay, so the last little part is we need to know, this is saying what angle gives you a tangent ratio of infinity or negative infinity. So I would say probably the easiest way to do that is to think about what the tangent graph looks like. So tangent graph does repeat itself a lot. So we already talked about the tangent at 0 is 0. What about at like pi over 4? What's the tangent at pi over 4? It is 1, because sine and cosine are the same there. So at pi over 4, it's at about 1. At negative pi over 4, sine and cosine are the same, except one's negative 1. So if you took pre-calculus, you probably remember the tangent graph just kind of looks like this. And again, I'm really just plotting. I kind of remember what the graph looks like, and I plotted a couple points referring to unit circle. So here's what they're talking about. It has these asymptotes. That's where this is approaching infinity and negative infinity. So in tangent, they get positive infinity. What angle was this where tangent is undefined? Pi over 2. So as x approaches pi over 2, that gives you a tangent ratio that approaches infinity. So right here, this is saying what angle gives you a tangent that's infinity. So that's pi over 2 for this guy. Okay, over here is where he's approaching negative infinity. And what is this angle? It is. So negative pi over 2 would be positive pi over 2. So add 0, subtract 0. No one cares about that anyway. So you add these together, and I would say your answer is pi. Am I close? That's it. So that's pretty tough. I'm not saying that you need to deal with inverse tangent all the time or anything like that, but that's where it's kind of nice to know the trig graphs. If you remember what the tangent graph looks like, it's a lot quicker. If you don't, it's nice to know the general shape. Obviously, it's periodic intervals the rest of the time. And if you know the general shape and you just do a couple of unit circles, right? So tangent of 0 is 0, the tangent of pi over 4 is 1, the tangent of negative pi over 4 is negative 1. So you give yourself some points to connect, and then you can kind of figure out the graph.
I guess you still have to know the balance, like,
Well, vertical asymptotes occur when you try to divide by 0, right? And since tangent is sine over cosine, these are occurring when cosine is 0. Cosine is 0 at pi over 2 and negative pi over 2. So maybe that's a little more efficient for you. I'm a very visual person, so. So again, just to be clear, I don't think on your AP exam you're going to have a ton of inverse tangent stuff. That still doesn't stop us from reviewing it and repracticing it. It's still good information for us. Okay, somebody have one more besides question 8, only because I want to save that for us all to be there at the same time. Okay. So I will not be taking your last 20 minutes from you this class. So you still got 20 more minutes before you go. So try to get another couple questions done. Just like last year, I don't have control over the Friday schedule. So sometimes you guys have Thursday to Tuesday to finish up homework, and sometimes you have the very next day. This just happens to be the very next day. So I need you to make sure that you finish up this assignment. The one exception is you do not have to have number 8 finished. When I see you tomorrow, we'll talk about number 8 together, and then I'll have you turn it in. So make sure you have the rest of it done with fidelity. So check your answers, learn from your mistakes, highlight things, write yourself notes. Make a document that is actually going to be helpful to you in the future.
In the fight against Alzheimer's, now matters because now we have treatments. Now we're seeing change because now we're making it.
0 for t, your denominator goes to 0, right? Okay, but as a fraction, if you take a number like 1 and divide it by a number that's going to 0, so I can't plug in 0, but I can plug in something close to 0. And then that gets even closer to 0. That's heading to infinity, which is why that approaches. If your denominator gets close to, and that's why when you have vertical asymptotes, like when you try to divide by 0 to get vertical asymptotes, as you get really close to dividing by 0, the fraction shoots to infinity on one side and takes it on the other side. So it's similar to that. Find a good way to do graphs like this.
guys finished or not. We got about 4 minutes here. So again, I would like you to stick with this, please, except for question 8. If you try question 8 and get stuck, we will talk about that one together. But then right after we talk about that tomorrow, I'll ask you to turn this in. So make sure you have the rest finished. Tomorrow won't be anything new, just getting better and practicing these 3 topics we've talked about: partial fractions, integration by parts, and now improper integrals. So that's what handout 9 is. Some extra practice just on those 3, and some extra practice with those 3 mixed in some other stuff, so you can make sure you can identify what type is which.